Let's take a look at solving systems of equations with 3 variables. Okay. So hopefully you watched the previous lecture, which was systems of equations with 2 variables. So this is just an extension on that. Okay. Example 1 here, we're testing this ordered triple. It's always alphabetical order, so X, Y, Z. And we are going to determine whether it's a solution. We're going to plug them into each one of these equations, and they need to all work, okay, for it to be a solution to the system. So we'll plug this one here. X was a 3, Y a -2, Z a 1. Does this really equal 2? 1 plus 1, yes it does. We like that one. I'll put a check right here. Okay, let's test the next one. 6 times 3 minus 4 times a -2, which turns that into a +8, plus 5 times 1, which is 5. Does this really equal 31? 26 and 5 does equal 31. We like that one. I'll check there. One more time because they all have to work. 5 times 3 plus 2 times -2, which will be a -4, plus 2 times 1 right here, which is 2. And does this really equal 13? 11 plus 2 does equal 13. They all work. So is it a solution? Yes. 3, -2, 1 is a solution to the system. All right, let's move on to solving. So we don't know the solution. We're trying to solve the solution or for the solution here. And we're going to do it by the elimination method or the addition method, I believe. Some books call it addition. Some books call it elimination. Same thing, doesn't matter. I have labeled each equation. It is easiest, especially if you have an instructor that you need to show your work for, to have them labeled so we know what you're doing when, okay? I am going to try to eliminate a variable just like we did in the previous section. The only difference is when we have 3 equations, we have to eliminate the same variable twice. So we are going to, here's my little tip, eliminate and it doesn't matter which one, but you have to do the same variable. So I'm looking at these and I'm thinking it's going to be really easy for me to eliminate X. So I'm going to move over here. I definitely need more room for this one. Here it is. Okay. So what I'm going to do is I'm going to take equation 1 and equation 2, and I'm going to notate it like that. Just copying it down here. And I'm going to add them together. And the nice thing about this is I can eliminate X pretty easily. Okay. I will get 1Y plus 2Z equals 3. Okay. I have eliminated X once, but remember I need to do it twice. Eliminate X again. This time I'm going to use 2 and 3. Okay. I'm trying to eliminate X. Well, here's what my equation 3 looks like. Equation 2, I'm going to multiply it by a 2, okay? So I'm going to run through this whole equation, multiplying everything by 2. -2x plus 6y minus 2z equals -12, because I multiplied by a +2. So that stays a -12, minus 2z plus 6 minus 2. Okay, and I like it because now when I add, those are gone. Y plus 3z equals 5. Okay, I am going to label this equation. So this one, blue one is this one is 4, and I'm going to label this one 5. So the 2 blue equations are what I'm going to use now to move forward. we had 3 variables. Now I have the 2 blue that are highlighted are just 2 variables, y and z. And it becomes like the previous section where there's 2 variables and you need to eliminate. So this time I'm going to use equation 4 and 5, and I'm going to eliminate either y or z. And I think I'm going to eliminate y, so I'm going to multiply equation 4 by a -1. Negative y minus 2z equals a -3. 5 I'm not going to change. And you're going to add. And we like it because those are gone. And we get 1z is equal to 2. Yay! Okay, so we have our z value, but we're not done because we need to go back and find our x's and our y's. Now, in theory, everything you've done has been correct, so you really can go back and use any equation you want. I like to use the ones I think are the least amount of work. So I'm going to take my z value and I'm going to back substitute it into the equation 4. Okay, so look at equation 4. Y plus 2z equals 3, which is y plus 4 equals 3, which means y is -1 when you solve it. So my solution is going to have an x, a y, and a z. I don't know x yet. I do know the y, and I know the z. Okay, now I'm going to take my y and my z, and I'm going to go back to any equation I want, because technically they all should be correct. And I'm going to figure out x. So I'm going to use equation 1, I think, and back substitute all the way to 1. X we don't know, minus 2y plus 3z equals 9. Okay, so x plus 2 plus 6 equals 9. X plus 8 equals 9. X is 1. There is the solution to the system. Now, to check it, you would plug it in to each one of these and make sure that they are all equal, like we did for the first example. Now, what does this mean? Let's take a look at this picture that I have right here. Okay. When you have equations with 3 variables, x, y, and z, it is a 3-dimensional plane in space. So if you look here, each one of those 3 variable equations we had represents one of the colored planes, okay? And when you have a specific coordinate point that works for each one of the equations, that means that that particular point is going through each one of the planes. So that means that those 3 planes meet at only one point. Now, 2 planes meet at a bunch of points, right? The red and the green meet at a whole bunch, but the red, the green, and the blue only meet at the 1. So, and that 1 point is 1, -1, 2, okay? Now, since we're talking about that, let's go back to here. So, image A is what just happened, okay? We could get situations where B is happening, and these 3 planes all line up and have a line in common. So there's infinitely many solutions. So that can happen, okay? We could also have a situation down here, like these figures. For A, there's 0 solutions for the entire system because all 3 planes don't have any points in common, okay? For B, it is also no solutions because there is no single point or single line where all the planes come together. Same thing with C. So there's actually 3 different scenarios where there's no solutions, okay? And there's the 2 scenarios where there's either 1 solution or infinite solutions. All right. Invested his inheritance of $12,000 in 3 funds: money market, municipal, and mutual funds. Okay. So I know that there's a lot of interest rates, but I'm going to just talk about what he originally invested. So no interest on it yet, just what he originally invested. We're going to do money market plus the bonds plus the mutual funds is the $12,000 originally invested. Okay. The next equation is going to be about the interest that each investment generates. Okay. So of the money market, 3% of that money market amount is the interest it gets. The bonds pay 4%, so 0.04% of interest on B dollar amount. And the mutual funds get 7%, 0.07 F. Okay? Now, this does not equal 12,000. That's how much interest is. John invested, there's another equation here. I don't know this number just yet, okay? John invested $4,000 more in the mutual funds than he invested in the bonds. So the bonds and the funds are not equal. One of them is more, okay? So which one is more? The funds is more, so we'd have to add to the bonds $4,000 to make that an equal, an equation, a valid equation. Okay, last sentence, the total interest earned for 1 year was $670. Now we know what the interest is equal to. All those of those interests equals $670. Okay, these are my 3 equations. I am going to adjust the third equation, okay, so that all my variables are lined up. So the first one is M. And my method for solving is going to be the same as it was before, which is eliminate the same variable twice. So I'm going to label these equation 1, equation 2, equation 3. Now, I'm kind of a sneaky mathematician, so when I see that equation 3 already has M eliminated, I'm going to choose to eliminate M. And I'm going to use equation 1 and equation 2, okay? So I'm going to take equation 1, and I'm going to multiply it by a negative 0.03. Here's why. I will have a 0.03 M. I will have, and I said negative, a minus 0.03 B, a minus 0.03 F, and it's going to equal, I got to do some math here, 12,000 times negative 0.03. Like so. Second equation I'm not going to change. And I'm going to add them together, okay? M is gone. We will have 0.01 B plus 0.04 F equals positive 310, okay? Now check this out. This equation doesn't have an M in it. This equation doesn't have an M in it. So I already have M eliminated twice. Okay, so I'm going to use those two now. And I'm going to eliminate another variable. So I'm going to call this one my equation 4. Okay. And let's get rid of F. If we get rid of F, we're going to use equation 3 and equation 4. And if we're going to eliminate F, that means equation 3 needs to be multiplied by 0.04. So I'll have 0.04B minus 0.04F equals 4,000 times, negative 4,000 times 0.04, which would be a negative 160. Equation 4, I'm not changing. And we add, okay? We add, F will go 0.05b is equal to 150. Divide by 0.05, and we get a b value of 3,000. And that makes me feel a lot better because we were dealing with a lot of decimals, but we're talking about investing money, and we had up to 12,000 to invest. So having a 3,000 there is kind of nice. Okay, and now we go back to any equation we want to back substitute. Now, I'm going to pick equation 3 to back substitute into, and I'm kind of doing it sneakily because if b is 3,000 minus f, and it has to equal a negative 4,000, subtract 3,000, divide by negative 1. F is 7,000. So now I know how much we have for B. I know how much we have for F. All three investments have to total $12,000. So if M plus B plus F have to equal 12,000, we don't know M, but we do know B, and we know F. Those add up to be 10,000. Subtract, looks like we got 2,000. So what do we know? 2,000 in mutual funds, 3,000 in bonds, and, oh, that wasn't mutual funds. What was that? Money market. This was money market. Bonds was 3,000, and then mutual funds was 7,000. And those are the three amounts that was invested. Okay. Okay, moving on to example 4 now. Let's look at example 4. I want to eliminate, let's go with x. Well, let's eliminate x twice. So I'm going to use equation 1 and equation 2. I don't have to do anything with those. So we'll just line them up, add them. X's get eliminated. Negative y minus 4z equals 7. I need to eliminate x again. This time, let's use 2 and 3. And equation 2 will multiply by here. Negative 5x plus 10y minus 25z equals 15. The 3 we're not going to change. So we'll just copy it down. And then we add these. Negative 3y minus z, silly Janine, and 23. Okay, now this is my equation 4 and my equation 5, and let's work with these. I'm going to eliminate y, so we will take equation 4 and multiply it by a negative 3. This will give me a 3y plus 12z equals a negative 21. Equation 5 I'm not changing. Add. I have 0 equals 2. So when this happens, either we made an error, and you can see how easily that can be done. I almost made one myself. Or it means there are no solutions. Okay? Which means that these three planes don't all have the same intersection point. Okay? We need to pick a variable and eliminate it twice. So it looks like y is pretty easy to eliminate if I use equation 1 and 3, and then I use 2 and 3. Okay, so that will be my plan. Oh. 1 and 3, and I'm going to eliminate y. So 2x plus y minus 3z equals 0, and x minus y plus z equals 0. When I add them, I get 3x minus 2z equals 0. I have eliminated y. I'm going to eliminate y again. Let's use 2 and 3. I'm going to multiply equation 3 by a 2. All right, so 4x plus 2y minus 6z equals 0. Equation 3 times 2 would be a 2x minus 2y plus 2z equals 0. Add, we get 6x minus 4z equals 0. So these are my two equations now. We'll call them equation 4 and equation 5. Okay, and I want to eliminate a variable again. Okay, so I think I'm going to multiply the number e4 by a 2. Okay, some of you I probably see or recognize what's going to happen, but so 6x minus 4z equals 0. 5 we didn't change, and we end up with 0 equals 0. Okay, since this is a true statement, there is infinite solutions. Now, how do we write that? So we're going to say the set of solutions are the x, y, z triple such that, we say such that when we see it. Okay, such that what? All right, well, I'm going to list 3 things in this row, okay? I'm going to talk about what x is, I'm going to talk about what y is, and then one of the variables has to be any real number. So there's it's not infinite x, infinite y, infinite z. There is a relationship amongst them. They have a specific relationship with each other. So I'm going to say z is, and this is a symbol that means any real number, okay? All right, so what is y and what is x? Okay, so here it's going to be an x equals, and here it's going to be a y equals. Well, if you come up to this, any equation, right? I'm going to use this one right here, okay? Our number 4 equation. Number 4 was 3x minus 2z equals 0. Okay, so I'm just going to make this a little thicker. If I solve this, 3x is equal to 2z, which means x is equal to 2/3 z. X is equal to 2/3 z. So is there a relationship with x and z? Yes, and that is the relationship. Are there infinitely many of these groupings? Yes, but they're not just any willy-nilly number. There's a certain number for each one. Okay, now I need to do the same thing for y. However, I have to go all the way back to one of the original equations. So let's go to the original number 3 equation. I'm going to put it right here. Original number 3 equation was x minus y plus z equals 0. And I'm trying to solve this thing for y. So I'm going to add y to the other side. X plus z equals y. Now, I'm not done though, because I want this equation to be just z's. Well, I know that x is 2/3 z. So one more time for good measure, 1z is 3/3. So it is 5/3 z equals y. Holy smokes. So what's my point? My point is this is the answer, and it's overwhelming, right? What it's telling me is that there are infinite solutions, but there's a relationship amongst them. If z is 0, x is 0, y is 0. If z is 1, x is 2/3 and y is 5/3. If z is 3, x is 2, y is 5, z is 3. Yes, we could keep doing this all day long and get infinitely many of these triples, but they have a relationship with each other, and that is the point. All right, that concludes our systems of 3.